Hello, dragons, and welcome to page 3 in your interactive notebook, called Prime Factorization. I can construct a factor tree to determine the prime factorization of a composite number. Prime number, a number blank, then blank, and has blank two factors, 1 and blank. Prime numbers are the blank blank of all numbers. Pause this video to copy this down now. Prime number, a number greater than 1, and has exactly two factors, 1 and itself. Prime numbers are called the building blocks of all numbers. Let's keep going. We're going to do an example together. We're going to do find the prime factorization of 600. We're going to create a factor tree. A tree. Here's how it works. Start with 600 at the top. And we're going to branch out 600. We're going to break it down using factors. So something times something makes 600. And the thing with this is we could all come up with something different. We could come up with 6 times 100. Or we could come up with 2 times 300. It doesn't matter which branches we use because we will all come to the same answer. So let's test it. Let's do 2 times 300. 2 is prime. I can't break 2 down into more branches. 2 is finished. I like to circle it. I call it a leaf. 2 is prime. 300 is still composite. Let's break it down. Let's call it 2 times 150. Two is prime. That branch is finished. 150 is composite. Think of something that would go into 150 nice and evenly. You might remember from the sieve activity that 5 would be a nice multiple, a nice factor of 150, because 150 is a multiple of 5. 5 times what? 5 times what? You said 5 times 30. You are correct. Five times 30. Now you might also remember from our sieve activity that 5 is prime. But 30 is composite. So we have to keep going down that branch. 30 we could do 5 times 6. 5 is prime. That branch is finished. 6 is still composite. 2 times 3. 2 times 3. Okay, now, if I take all the leaves at the end of the branches, I can write a multiplication expression. I can write 2 times 2 times 5 times 5 times 2 times 3. But I'm going to write it nice in order. I'm going to write 2, check, times 2, check, times 2. I like to keep all the 2's together. Check, times 3, check, times 5, check, times 5 again, check, Got them all. Well, will that get me 600 if I multiply all those factors together? Let's test it. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. What's 24 times 5? What is 24 times 5? Let me go over here and do a little scratch work. 24 times 5 is 120. And it says, times it by 5 again. 120 times 5. Oh, 600. So if I multiply all these back together, I get 600. But there's one other special step you need to know, and this is why you had to learn exponents. I want you to find things that would be able to be written in exponential form. This is repeated multiplication. And this is repeated multiplication. That means I can write those in exponential form. The base would be 2. How many 2's do we have? 3 of them. So it would be 2 to the 3rd power. We can't change 3. There's only one of them, so leave him the same. But we can change 5. 5 would be the base. And to what power? The 2nd power. If I were to multiply this out or pop it in a calculator, it's still going to be 600. That is how a factor tree works. Let's go to the backside and experiment with the factor tree once more, using 600, but going down the tree a different way. I'm going to use 600 again, but last time, what did I do? 2 times 300? Okay, let's not go down the tree the same way. Let's use different factor choices and see if we get to the same answer. I know 6 times 100 would get me 600. Both of these are composite. 6 is 2 times 3. 2 is prime. Finished. 3 is prime. Finished. 100, how about 4 times 25? Both of those are still composite. 4 is 2 times 2. We're finished with that because prime, prime. What is 25? 5 times 5. Both of those are prime. Let's write it out. 2, check. Times 2, check. Times 2, check. Times 3, check. Times 5, check. Times 5, check. Looking familiar? It is. It's identical. Let's write it in exponential form. We've got repeated multiplication there. Repeated multiplication there. 2 would be your base. 3 would be your exponent. The base 3 can't change because there is no other 3's. And on 5 times 5, 5 would be your base, 2 would be your exponent. If we multiply these out or use a calculator to check our work, I assure you, you would get 600. Following this video, you have prime factorization task cards to work on. Good luck, and thank you.